Okay, carrying on to question 6. So we note that we are given dinitrogen tetraoxide N2O4. It dissociates to form nitrogen and oxygen at a particular temperature. So this question doesn't even want to give you the temperature. All right, we are told that given 20% of it dissociates at a total pressure of 300 kilopascal, calculate the Kp value at this temperature. Okay, so again, we are not given equilibrium amounts. We need to draw the ice table. Okay, so this is the initial data that we've been given. As usual at the start, we're gonna have to start with zero product. Based on the mole ratio, we find out how much was the change and basically just add up each individual column to get our equilibrium amount. Okay, so to get our total amount of gases, this step is crucial because then we will need the total amount to get our mole fraction. Okay, so we plug in all our mole fractions into the expression and we calculate for the Kp. Okay, all this seems easy if you're just looking at it, but you have to try doing it and pressing the calculator for yourself to know how it works. All right, so I hope you're going to do that. Okay, so what is the relationship between Kc and Kp? Without going into too much detail, if you are all right with just taking note what's the main relationship, this is how they are related. All right, so we actually will need to substitute your concentration, right? Or your concentration for this expression. All right, P is literally equals to concentration RT. Okay, so when we do this substitution here, we allow Kp to be linked to concentration. All right, once we do that, we do some rearranging and we notice that we can actually arrange it such a way that Kp can be related to Kc. All right, this is not going to be too relevant to you guys, but if you're interested to know, you can actually look at how the manipulation was done. Okay, next we come to this part. So we moved on from the calculation part to back to the theory part, all right? This principle is very, very important, all right? The H2 students will need to remember this definition, all right? What does Le Chatelier's principle say? It says that a system at equilibrium is subjected to a change, right? If that change disturbs the equilibrium, the system will react in a way to counteract that change so that it can re-establish equilibrium. Okay? Okay, we call this Le Chatelier's principle LCP for short. This LCP only applies to system that's already at dynamic equilibrium. All right, so please take note of that. Okay, we're going to look at 4 factors, which is namely concentration, pressure, volume, catalyst, and temperature to see how it affects equilibrium.